Hello and welcome to my YouTube channel. Today we're going to talk about the God equation and the quest for cellular oxygen in times of COVID-19 crisis. This is a tale of two chemicals. When a mysterious chemical is added to human blood, it is decomposed to yield molecular oxygen by a magical chemical, and this reaction has been used to oxygenate stored blood before transfusion. This mysterious chemical is hydrogen peroxide, and the magical chemical is the enzyme catalase. And the equation is two molecules of hydrogen peroxide are catalyzed by the enzyme catalase to yield two molecules of water and one molecule of oxygen. Interesting, but who discovered this mysterious chemical hydrogen peroxide? And who discovered this magical chemical catalase? Hydrogen peroxide was discovered by Louis-Jacques Thénard, a professor at the Collège de France in 1818. The term catalysis was coined by Johannes Jacob Berzelius in 1835. Catalase was first called Hamase by Oswald, a professor of physical chemistry at the University of Leipzig, who assigned studies involving catalysis to a number of his English-speaking students. The name catalase, however, was first given by Oscar Loew in 1900, although it was first observed by Louis-Jacques Thénard in 1818. So, what is the nature of this hydrogen peroxide? Hydrogen peroxide is a water-miscible pale blue covalent liquid capable of passing through cell membranes. High levels of hydrogen peroxide, more than or equal to 50 μm, is considered cytotoxic. If hydrogen peroxide is toxic, then why is it produced? The production of hydrogen peroxide in cells is a defense mechanism to protect the body from the dangerous and deadly superoxide. What in the world is this superoxide? Superoxide, one may think, as the name suggests, is oxygen with superpowers, but no. It is a supertoxic form of oxygen which causes DNA damage. In other words, it's the evil twin of oxygen. Ha ha ha. How is this evil twin superoxide produced? Electron transfer occurs at all times in our body, but sometimes it is transferred to oxygen, converting it into a highly reactive superoxide which damages other molecules. In cells, superoxide is produced from oxygen by xanthine oxidase, NADPH oxidase, and mitochondrial electron transfer system. In phagocytes, superoxide is produced in large quantities by the enzyme NADPH oxidase for oxygen-dependent killing mechanism of invading pathogens. Here we see molecular oxygen being reduced to superoxide by a free electron. What the hell is so dangerous about superoxide? Superoxide promotes superreactive hydroxyl radical formation, which in turn causes DNA damage in cells of all types, and that is what makes it so dangerous. Here we see that molecular oxygen is reduced to superoxide by the first electron. The superoxide is again reduced by the second electron to hydrogen peroxide. Now, the enzyme involved in the conversion of superoxide to hydrogen peroxide is superoxide dismutase. Further, hydrogen peroxide is reduced by the third electron to the highly reactive supertoxic hydroxyl radical. So, oxygen indeed is a double-edged sword. Is there a twist to this evil twin, double-edged sword, tragic tale? Yes, and that is where our magic enzyme catalase comes to the rescue. Catalase decomposes hydrogen peroxide into oxygen and water before superoxide can form DNA-damaging hydroxyl radicals. And the equation is 2 molecules of hydrogen peroxide are decomposed to 2 molecules of water and 1 molecule of oxygen by the enzyme catalase. Where does this hydrogen peroxide occur in the human body? In the human body, hydrogen peroxide primarily occurs in the lungs, gut, and the thyroid gland. According to a study published in the Nature journal, hydrogen peroxide arrives at the site of infection 17 minutes prior to the WBCs and acts as a Pied Piper summoning white blood cells to the site of infection to promote healing. Where is this magic enzyme catalase found in the human body? Catalase is predominantly found in the red blood cells and the liver cells, and is produced in both the marrow and the liver cells. Human catalase is expressed in every organ, and the highest levels of activity are measured in the liver, kidney, and the red blood cells. So what makes catalase a magic bullet? Catalase prevents the accumulation of hydrogen peroxide and protects the cellular organelles and tissues from damage caused by hydrogen peroxide, which is continuously produced by numerous metabolic reactions. Catalase is used as a therapeutic agent against numerous oxidative stress-related and age-associated neurodegenerative diseases, including Alzheimer's, Parkinson's, bipolar, cancer, and schizophrenia. Catalase prevents premature graying of hair and is anti-aging. It is also considered a longevity enzyme, which is an abundant source of catalase. Yeast is a highly abundant source of catalase. Okie dokie, but how is all this relevant to the current COVID-19 oxygen dependency? According to a study published in the British Journal of Anesthesia 1966, Volume 38, Dr. D.C. White and Pierre Teasdale calculated and confirmed that under all circumstances, the addition of 1.19 ml of 100 volume hydrogen peroxide would ensure an oxygen saturation of 100%. 1 molecule of catalase can split nearly 42,000 molecules of hydrogen peroxide in 1 second at 0 degrees C, as recorded by Stanbury, Weingarten, and Fredrickson, 1960. So now do you see the connection? Hydrogen peroxide is used to oxygenate stored blood before transfusion. So you're telling hydrogen peroxide can be used to target and kill infected cells and simultaneously produce oxygen? Are there any drawbacks? Oxygenation of blood using hydrogen peroxide may lead to formation of methemoglobin and may cause damage to the red blood cells, may also lead to hemolysis due to accumulation of water in the blood, and may result in emboli formation, reduction of the oxygenating capacity of the lungs by small emboli residing in the pulmonary vascular blood. So is there another twist in the story and yet another magic bullet? Yes, Methyleneblue acts as an electron shuttle which allows NADPH to reduce methemoglobin to hemoglobin. So, 1 molecule of Methyleneblue can reduce numerous molecules of methemoglobin, thus freeing hemoglobin to transport oxygen. This is the rationale behind using Methyleneblue in the treatment of COVID-19 oxygen dependency. However, accumulation of water in the blood and embolism pose a major challenge. Further research into the mechanism of these magic molecules may provide clues to connect the dots and generate solutions to COVID-19 oxygen dependency as we continue on our quest for the God equation to effectively and efficiently manage COVID-19 crisis.